Thank you, and thanks to Mobex team for hosting us on your platform. Today, we'd like to share the great vision for advancing the usage of simulation and the valuable data it generates. We believe that enhancing usability and shareability is the key to unlocking its full potential. Integrating a scalable, cloud-based hosted workflow on top of a traditional desktop-based simulation represent for us an important step forward on this journey. The current automotive market, especially if we focus at the vehicle development, challenges the car maker and their suppliers on a lot of different tasks. Reducing the development time and its cost, even now that the automotive product is a complex system as never has been before, ask to automotive industry innovation, integration, and collaboration to be able to keep its competitiveness. In this scenario, VI-Grade aims to support the automotive industry with its vision and its products lineup. At the heart of the VI-Grade offer, we have VI-CarRealTime, a vehicle dynamic simulation platform. VI-CarRealTime is a unique vehicle dynamic model dedicated to development process from the concept stage to the product sign-off. Its capabilities are the foundation of its success among our customers, but to always increase its effectiveness in the industry workflow, VI-Grade continuously open it to new features and capabilities, together with completely new products to this portfolio. With the last 2025.2 products release, VI-Grade has introduced its new online platform, VI-DataDrive Cloud, and integrated in VI-CarRealTime all the needed functionality to leverage this new tool. A conventional desktop-based workflow made up of a model definition when you put all your data together, a model extension, typically a co-simulation with MATLAB Simulink for the automotive industry, but could be also using the functional mockup interface and the FMU models. Then you move to a local execution of your model, you submit your simulation, and finally you review your data. Now all this can be switched to a cloud-based workflow. VI-CarRealTime, with its investigation and diagnostic mode, already enable multi-run design of experiment optimization and automated reports. But moving all this procedure on the cloud increase the efficiency of the simulation process and enable new possibility for both models and data sharing. With all this, our workflow can change and become something slightly different, because you incorporate in VI-CarRealTime all the external component typically used through a co-simulation in the auxiliary subsystem technology CarRealTime incorporates to include a third-party model in its system. With this self-contained vehicle model, at this point, you can move and upload it on the VI-DataDrive Cloud platform. And as you are in the cloud, you can remotely execute the simulation, maximizing speed and resources usage. Next step is finally, with the results stored on the cloud platform, post-process them and synthesize in a report that could be shared with all the authorized people. And now let me leave this virtual stage to Jodie to have the possibility to discover how VI-CarRealTime and VI-DataDrive work together.
Thank you, Paolo, and hello, everyone. So in order to showcase VI-CarRealTime and VI-DataDrive Cloud, as well as the novelties of version 2025.2, we put together a demo, which will showcase how to add your custom components by compiling a Simulink model to VI-CarRealTime and create a self-contained model Paolo was talking about. Then we will create custom metrics and prepare a design of experiment and an optimization with the investigation mode, the latter one being a new feature of 2025.2 version. We will run these events in parallel by deploying the investigation on the cloud. And thanks to the integrated post-processing, we will be able to understand the trend and effects of our changes. Finally, we will ensure that all KPIs are met throughout the process by using the diagnostic mode. So before I jump in with the demo, just a little context on the story we put together. So we are part of the powertrain team, and we are looking to optimize the position and the mass of the battery based on comfort. And we're getting the vehicle model from the vehicle dynamics team, who obviously have some ride and handling KPIs that it will like to maintain throughout the process. So we'll get that model, make some modification, and ensure their KPIs are still being met while we maximize our comfort. All right, so let's jump straight into the demo. So the first thing we do is load the model that the vehicle dynamics team sent us. This is a sedan-car hybrid. So for those of you not familiar with CarRealTime, we have a subsystem organization. But in this case, we're going to look at the powertrain. So it's a hybrid vehicle with a combustion engine and two in-wheel motors at the front. And what we're going to want to do first is review the KPIs that the vehicle dynamics team has put together. So we're using the diagnostic mode. It's a mode where you can use some events that are either predefined or custom, and you can define your own thresholds and KPIs inside. This way, you can run automated tests on a single vehicle model and verify whether or not it matches. In this case, we're going straight to the VI-DataDrive Cloud. On the dashboard, we can see all of the simulation made by our teammates. And in this case, I'm going to look at the diagnostic that the vehicle dynamics team ran beforehand. So here we have some simulation input details. I can see who has done what, which teams are part of, and I can download the inputs. So the vehicle models that they put in. We then have all of the run details, whether it succeeded or not, which version was running, the progress, and I can also download the output results from the cloud. The workflow graph shows you the process. So here you can look at the logs that you're used to in VI-CarRealTime already. You can see what went on, you can see if anything happened, and you can see that vehicle events run in parallel. But we're going to look at the simulation report from the diagnostic mode. So we have our test statistic, and most importantly, we have the status. So we can see at a glance whether our test passed or not. Obviously, the vehicle dynamics was satisfied with their own vehicle. It has a 2300 mass, and if we're looking at the acceleration, it has a time of 4.3 seconds, which are going to be the variables we're going to look at throughout the story. So we want to integrate our own battery model and electric motor models, as well as our control logics. And we've done that in MATLAB Simulink. So this is our MATLAB, our Simulink model. So we have the CarRealTime solvers that's provided with VI-CarRealTime distribution. We have some custom inputs that we've created. So state of charge, current voltage, and regeneration. And if we go back to the drive line, we can see our models. So we have our components models and we have our control logics models. And we want to integrate that to CarRealTime. So we provide a plugin where you simply compile, and it's created as a subsystem for CarRealTime, which we've gone ahead and done that already. So if you look at our vehicle model, it's exactly the same. It has all the same subsystems. The only thing that changes, we have this new auxiliary subsystem, which is what we call external models. And if you look into it, you can see all of your MATLAB Simulink parameters that are available for tuning and for changing. So this is a good way to tune some control values. Now, if I go on to the test mode, where we define all the events that the vehicle model is going to run on, we have two events. The first one is a straight maintain event. So we are going to do that for the comfort analysis. We have a cleat test, as you can see in our plugin VI road. We can see that there's a step in the road, and we're going to look at accelerations at this level. We also have a max performance event, so our lap time optimizer. We are running on a racetrack that is provided with VI-CarRealTime distribution for the sake of the demo. We have our road graphics files, road data file as well. Everything is defined here, and we'll be able to run that. So I did that for the vehicle dynamics model that we received, and then we did that with our new control logic that's for the moment not optimized. These are the exact same events. The only thing that changes the vehicle model. And if I go to my review mode, which is where I can actually look at my results, I can select my two max performance event and visualize them in VI Animator. So you have the graphics board and you have some plots. Here, we just want to look at the difference we introduced by compiling the MATLAB Simulink model. So if I look at my battery state of charge, I can see the red line is the initial model and the blue one is mine. So we can see that we have introduced some additional parameters that were not modeled initially, such as state of charge, current voltage, and regeneration. Now, what we want to do is optimize this battery pack. So to do that, we're going to go to the investigation mode. This is going to allow us to do some design of experiments and optimization. So I'm going to load the design of experiment. And it's going to be a little bit of, there's a lot going on. The first part is a candidate. So these are all of the vehicle parameters and also the MATLAB Simulink parameters that you can promote to factors and study the impact of. So here we have the battery position, mass. We also have some information about our motors. And we're going to define their values. There are several ways you can use to do that. They're listed here, so continuous or discrete way with respect to nominal value. But in this case, we actually use a custom workspace. So this is a CSV file where we go ahead and specify the value of each version. So first version would take these exact values, and this is really useful if you're trying to reproduce configuration you already know of, for instance. Now, once we've done that, we're going to go to the responses. This is our outputs, what we're interested in. So you can retrieve that directly from the VI-CarRealTime model or its auxiliary subsystems, but you can also do some custom response. So we do that through a Python script, where you can take a number of output channels from the VI-CarRealTime model, feed them to that Python script, and then output your own response. And we've done that for the fast Fourier transform and the first peak, the natural frequency of the acceleration. We have that for our max performance, and we have that for our maintain event. Now, if I were to run that locally, that would take a lot of time. There are a lot of simulations to go through, so we want to publish them on the cloud. So we can use a publish function that will create a zip file containing all of the files that I need to run the simulations on the cloud. So if I go back to my VI-DataDrive Cloud that we were on at the start, we were on the dashboard first, but we also have an upload and run section. So here you can select the team that you're a part of. Everyone having access to the team will see your simulation. And then you can choose the zip file that's been created in that moment. So this is the archive DOE webinar, and then it created that zip file. So loading this one, you would just start the investigation. We've done that ahead of time because it does take a little bit of time. It's not instantaneous. So we preloaded all of this. So my colleague did that. You can see that all 79 events have been run, which if I did that on my computer, it would have taken at least 8 hours. And I can see that all of my events were running in parallel to each other. So that's where VI-DataDrive Cloud is really powerful. If we go to that simulation report, we can see our events. So we have the max performance events and the maintain event. We have our version identifier, all of our parameters and outputs. And we have that lovely spaghetti graph with the version, the factors, and then all of our responses that we've defined. Now, we are going to look at the chassis acceleration, we want to minimize that. So ideally, we would look at one of the spaghetti strains at the bottom of the graph, but we can also go back to our table and sort our results from smallest to largest. So you can see here, this is what we did. And we're going to look at the 5 best versions. So we have version 8, 16, 24, 31, and 38. Yeah. And we're going to look at this version on the max performance event. So you can see here, these are the lowest acceleration value at the chassis point. And now we're going to look at max performance, look at the fastest lap times, and then out of these 5 best configurations that we identified before, we're going to look for the first one that appears. So in this case, that would be version 24. So version 24 maximizes comfort, but it's the one that degrades lap time performance the least. So this is the one that we're going to use as a so-called best version for our study. So I can download the outputs and then study them in VI-CarRealTime locally. And when I put them back into VI-CarRealTime locally, I can choose to either apply a variant, which would be the common way that users are familiar with, where you just choose a version that you want to apply. Now, you can do that, or you can use one of the new features, which is the override file. Here you can see the battery mass is much heavier than it was before. It was 300 to start with, and then it's 500. When you apply that variant, the model is modified, but it's not saved. So here you can see in bold which subsystem have been modified, and this will apply every time we run a simulation. So we want always to keep the same events, just in the vehicle models. So we went ahead and duplicated that already, and this is with version 24, as I mentioned. But now we have a good version, but we don't really have the best because we predetermined the version we wanted to try. This is where the optimization comes into place. It's set up as the same way as design experiments, but your factors are defined by their lower bound and upper bound, in which the optimization will look at values. So you can see optimization here. We have a least square solver and our function weights, which is to what extent we want to minimize our responses. This -1 here is because we actually want to maximize state of charge and not minimize it. So we just put the negative sign. Now, same process. You can zip that and then load it onto the VI-DataDrive Cloud. Again, we went ahead and done that already for you. So if we load that result, I can go straight to my simulation report and look at the results. So here you can see we have our single optimization event that's run on the cloud and see that everything succeeded. But going to the simulation report, we want to look at the best version. So here you have all of the information that you've defined into VI-CarRealTime, and you have directly the solution with all of the values for each of the candidates, and then the value of the objectives that gave this best solution. So you can retrieve them here. So here we have our same thing, max performance maintain event, and I can look either order by chassis like I did before, but actually we were running an optimization. So what I want to do is actually find the solution. And the solution is only one, and it's the one that finds the best compromise between comfort and lap time. And in this case, it will be version 23. Now I can look at the spaghetti graph and try and figure out which is the best, but the optimizer already did that for me. So all I need to do, well, if I want, I can look obviously at the max performance results, but once again, the optimization process that it found the best compromise between comfort and ride and performance. So I can go ahead and download these results and then load them back to VI-CarRealTime. It's the exact same way that we did before. Again, we could use the apply variant feature. but you've seen that already. So now we're actually going to look at the auxiliary override files that I wanted to talk about earlier. So same test mode, we are going to reproduce the exact same fingerprint, just change the naming for clarity. But here you can see I just checked the box that says vehicle override file. And this is a file where you go ahead and specify only a few parameters with a dedicated user interface. So here you can see that the battery mass is very close to 500 kilos, slightly less. But you can go ahead and specify that and then apply it over your vehicle model. So you can have a single vehicle model and then as many override files as you want. Now, when you run that, we want to see the impact of our changes. So we're going to look at the max performance events for all 3 versions, and we're going to load that to VI Animator. So in red, we have the original vehicle model with our control logics that's not optimized. Blue is going to be the model with the DOE, and green is going to be the model with the optimization. And if we look at speed, you can see the impact. So red is not optimized, and you can see it's kind of the most performing. And green is going to be less performing, which is normal because we've optimized comfort. Now, we've optimized comfort, and we did try to account for lap time when we did our studies, but we're not really sure that doing so, we were still respecting the KPIs by the team. So here you can see the impact also on current, you could look at state of charge, and you can obviously add any output channels that you want. But to make sure that we're still meeting these results, you can look first that your comfort is actually how you expect it. Because so far we're just looking at lap time and performance, but we want to see first that comfort is actually working as we expect. So we added a script file embedded into our event, and every time we ran simulations, it was generated a custom post-processing. So if I'm looking at version 23, for instance, I can look at my graphs that I've predefined thanks to Python scripting. So this is a very simple one. You have the chassis vertical acceleration on the first graph in function of time, and then we have our fast Fourier transform with the acceleration and the peak. So the amplitude is the values that we were looking at in our investigation mode, and the peak natural frequency was also in our response parameters. So comfort is as expected. You can obviously do some more complex post-processing, but let's look at performance, making sure that we actually met the vehicle dynamics team KPIs. So what we want to do is take the exact same diagnostic mode as they gave it to us. We don't need to have any expertise into right and handling performance. We just apply that to our own vehicle. And we can do that with the vehicle override files that we were using before. Now we can run that locally if we want, but we can actually run it on the cloud. This way the vehicle dynamics team also has access to it, and they can review the results directly in the cloud. So we loaded that, and we're going straight to the simulation report. And we can see that everything is all green, so that is good. You can see that our mass increase, we were at 2300, we're at 2500. And we're going to look at our acceleration time, which was 4.3, and it's now 7.4. So as expected, it's a bit worse. We have a heavier vehicle optimized for comfort, but it's still within the boundaries of what's acceptable for the powertrain team. Now, the vehicle dynamics team, which can now download the input model and then reuse it directly in their own studies going forward. So VI-DataDrive Cloud really helps with your teamwork and avoids the numerous team situations that we now work with. So just as a summary, the main benefits of the VI-DataDrive Cloud allow you to do faster decision making. It allows for scalable and efficient simulation. You can load very heavy investigations or optimization and have them run outside of your computer, so it doesn't catch on fire. And you can actually continue working on VI-CarRealTime on your computer while those are running. You have increased flexibility thanks to the auxiliary subsystems that we mentioned at the start of the demo. So compiling an external model, be it MATLAB or FMU, to VI-CarRealTime allows you to work in one single package entity and loads that on the DataDrive Cloud, which also makes for easier sharing across teams, OEMs, and suppliers. And obviously it enables teamwork, as anyone in a single team can upload simulation, reviews that uploaded by others, and this really helps in making people work together. In the future, we're looking to add in built-in model modification to VI-DataDrive Cloud, as for now it's only done through VI-CarRealTime locally. Extensive cross-processing will be made available so that non-simulation experts can have some more intuitive graphs to look at. And all in all, we are looking to make it an encompassing tool for non-expert users. So for now, DataDrive Cloud is really intended to people who are familiar with simulation and expert in their own field of simulation, but we're looking to make it also available to components experts so that they can interact with the simulation team in confidence using diagnostic mode, investigation mode, and DataDrive Cloud.